All right, so the first strategy we're looking at is getting them to have the same base. That's a 2. That's a 2. If they have the same base, then I don't need to look at those. I can just look at the exponents. The problem we're doing right now, these have an 8 and a 16. So when you first look at the problem, they might not be able to be written as the same base, but if they can, this is your easiest bet. There is another way to solve this, but it's not so easy. So if you notice the 8 and 16 have something to do with each other, then the best way to do it is rewrite them, 8 and 16, as the same base so that you can cross out the base. Power to a power, you multiply, and then we're solving here for x plus 4. And then we're solving, so we're going to subtract 3x from both sides, subtract 4 from both sides, and we have an answer. Okay? Once you get them out of the exponents, it's just algebra. So that's your first goal. Try to get them to have the same base. Can I rewrite these with the same base? Power of 2, right? 2 to the 5x. And what's the square root of 2? 2 to the 1/2. Now I don't need my 2's anymore. Solve that equation. 1/2 divided by 5 is 1/10. X equals 1/10. And we're done. If you want to, you can plug the 1/10 back up there. If you plug 1/10 in your x, you get 5/10, which is a half. So you get 2 to the half equals square root of 2. Anybody need more time? Writing? Okay. Can I get them to have the same base? A 3 and a 2? No, right? Cannot. So that's not going to happen. Positive and negative powers? I don't know. I would just do the log of both sides. Oh, can I have an exponential equal a negative? When you graph that 3 to the something, it's only going to be above 0, right? So it's never going to equal negative 2 because this is never going to keep, going down. So if you were to try to solve that, you would get no solution. There are some methods. What I would do if I saw that problem, I would probably start with the other thing I told you at the very beginning. If you're stuck, try switching, because this is one-sided. There's an exponential on one side and just a number on the other. So what happens if I switch it? I get log base 3 of, and here's your problem. You cannot take a log of a negative, so there's no solution. So that's how I would do it algebraically, but also you can do it like visually if you notice you have an exponential can't be a negative. Okay? We're going to get to that method some more in a little bit, but that's probably what's, this one is if you have a log on one side and a log on the other side, then you can just cross out the logs. But you have to have a single log and nothing else in front. So that's where we're going to use all the properties to kind of get that to happen. All the condensing, stuff like that. And then, we didn't even get to that yet. But I can use that in reverse. So what if they don't have the same base? What am I going to do if they both have exponents and 5 and 4 cannot be rewritten with the same base? We can't because they both have exponents. Nope, we can't. You can log both sides. And you can use whatever log you want. So you can use log base 10 or ln or log base 4 or log base 5. It doesn't really matter. So just log it. Log both sides. Because I can do whatever I want to both sides of an equation, right? And log is just an operation. So I'm just going to log it. So I'm going to put log in front of both sides. And I'm going to use log. You can use ln because it doesn't matter. As long as you use the same thing on both sides, that's fine. Why is that helpful? Because what's the rule with exponents with logs? So I can put that in front, and I can put that one in the front. Okay, now this is where you kind of have to train your eyes. Log of 5 and log of 4 are just numbers in your calculator. This is just a number, and this is just a number times x. So we're just going to treat it like a number and try to solve for x. So if I'm trying to solve for x, I probably should distribute this first. So I have x log 5 plus 2 log 5. When you multiply big numbers, they go, or whole numbers times logs, they just go in the front. This assignment is going to need to show a little bit more work because you're going to have to show these steps. Yeah. When you're solving and you have an x on both sides, what's the next step? Get the x's together on one side. So I think I'll just move this one and subtract it over to the other side. So it's not over there anymore, it's over here. And then, kind of working backwards, they both have an x in them. So I can take the x out. That's just a number. And that's just a number. So now I have a number equals x times a number. How do I get x alone? Divide by that number on both sides. So that number right there, log 4 minus log 5, is going to go over there. That is a good question. That depends on the textbook. Oh, goodness. They used ln and they wrote it differently. But that's the answer, so I would accept it that way. The easiest way to check your answer is going to be to type it in. So let's type this one in, and then I'll show their answer, and we'll type it in. Because when you type this in, what do you need to be extra careful of? Top and bottom. And remember, when you push log, it's probably going to start one. So you're actually going to have 2 here, and here, and here. So you got lots of parentheses going on. Parentheses, 2 log 5 divided by log 4 minus, close. Okay, so I got negative 14.425. That would be my x. Seems weird, but we'll check. Okay, so I'm going to move this a little bit. They said ln of 1/25 divided by ln of 5/4, which is ln of 5 minus ln of 4. That makes sense. Yep, negative 14.425. So if you want to check your answer in the back of the book, you're going to have to type them in, because that decimal does equal their answer, but obviously yours does not look like theirs. They just used some more rules of logs, like where they had the subtraction, they turned it into division. But it's all the same thing. Okay, so that's definitely one of the harder ones. When there is an exponential with different, that's fun, it all moved, with 2 different bases and both sides have exponents. If only one side had an exponent, I would just convert to log and be done. It'd be much easier. So this is why, if you notice that they both have the same base, I could solve this problem, or whatever it was that we did a minute ago. I could solve it this way, but it's much easier just to turn them into 2's and do it that way. It's not required, but it's easier. So there's more than one right way. Okay, what else do you have to remember to do first? All of these were set up ready to solve with exponential or log. With this one, don't forget your basic algebra skills. Undo everything you can first. What is in the way? The 20. We can't undo e with a 20 there, so it's got to be alone. So we got to divide by that 20 first. So if there's anything else besides your exponential term, you need to get everything else alone. There we go. So simplify first as much as you can with basic operations like addition, subtraction, and division and multiplication. Then it is an exponential equal to a number. Yes, so you can, there's more, again, there's more than one way to solve these, which is why they can be confusing. So Hannah, did you say you want ln both sides? Okay, so you can just stick ln in front of both sides, and how does that help us? So now I have ln of 5 equals 2t, so I would just type in my calculator ln of 5 divided by 2. And I have it written exactly the same way this time. So they aren't even doing the decimals. If you want to stop at that point, that's fine. If you like I said, if you compare your answers and yours doesn't look the same, type them in, because it might just be a different form, because there's more than one way to write that thing. That thing. Okay, so what do you do first on this one? The 5 and the 4, right? Minus 5 is 7, and then divide by 4 is 7/4. So then you'd have 5/4 and 12/4, because you would have to divide every term. So it's easier to use your Algebra 1 undo in reverse order of operations. If it's E, you can ln. So last time we just stuck ln on both sides, which is perfectly fine. We can do that again. The other way to think about it is to convert. So if you switch this, you would have log base E, which is ln, of that equals that. It's exactly the same thing as taking ln of both sides. They just switch sides. So whichever way you think is fine, divided by 2 is the answer. That is perfectly fine. Not sure if they left their answer like that or not. See, they wrote theirs. Oh, they just wrote the 1/2 part in the front of their answer, but it's the same thing. Makes it harder, right? Because there's more than one way to do this. And different teachers teach it different ways. So, yep. So sticking the ln in front. When there's an E, that's pretty much the easiest way. Sometimes, well, with exponentials, you don't usually get extraneous solutions, because what's the domain of any exponential? All real numbers, right? But what's the domain of a log? It's only positive numbers, right? So when we start solving problems that start out with logs, there might be solutions that are extraneous. And whenever you have a quadratic, you might have solutions that are extraneous. Oh, this is different about this book. So this one connects back to something we did a long time ago, solving equations in quadratic form. So notice that 2x, there's only going to be a couple of these. I'm going to get the 56 on this side. This is a trinomial. Let's see. Do you remember when I said, yeah, it is. There's 3 terms. I'm probably not going to do it with this, but do you remember when I said let a equal something? So this would be a squared minus a minus 56. Can you solve that problem? So you have to just recognize that those are doubled of each other. So a minus 7 times 8, right? A equals, but a is not a is e to the x. So e to the x equals 8, or e to the x equals negative 7. So what does x equal? So x equals ln of 8, or x equals ln of negative 7, but it can't because that's a negative. That was a lot of steps. So you can kind of skip the middle step if you see that this and this, you could just like right here write e to the x and e to the x. But it's up to you. There are like 2 of those on the homework. So just if you notice that there's an e to the 2x and an e to the x, then you're doing a trinomial. Right, because those cancel. Because I want to solve for x, and I'm not done until x is alone. So I took the ln of both sides to get that alone. And when I did that, can't take a log of a negative, and you can't take a log of 0, because it's not in the domain. Okay, that was a tricky one. Ready for the next? See how far we got. Okay, so whenever you're solving a log, always check your solution, because they can be extraneous. There we go. Okay, what do you do first? Get rid of that 3. So now there's a 4 here. Next up, get rid of the 2. Now I have an ln that's all alone, and I'm stuck. So switch it to e. So what? Use the e. You can like stick a big E here, and then you get x equals e to the 2. Or you can go e to the 2 equals x. You can do the convert thing. Convert or stick e on both sides. E squared. That's the answer. It's a decimal. I don't know what it is. But. E to the ln or undo each other. And it's power, yeah. You're raising the equation up into the exponent. Earlier we got the exponent out. Now we're putting it back up there. The other way to do it is this is base e, right? So e to the 2 equals x. You just do the convert. I'm sure that e squared is how they left their answer, yes. Okay. Want to do another one of those? Sure. I don't know how much time we have, but we'll see. Divide by 2. My shirt is writing ln of 6x equals 7/2. Undo that with e, so I'll do it the other way this time. E to the 7/2 equals 6x. Divide by 6. E to the 7/2 all over 6 would be fine. We'll see if they left it that way. Oh, yep. That is the same thing. They just pulled the 1/6 into front. So it's the same answer. Too fast? Are we good? Okay, what's the difference here? Oh, yeah, we don't need to do that. If you wanted to, you could graph them. ln of 3 looks like this. Or ln of x looks like this. There's 3. Where do they cross? So they cross at e to the 3. I think this is the last strategy. If you can get a log with the same base on the same side, then you can cancel those out. So if I have ln of this equals ln of that, I basically raise both sides to the e, and they're both gone. I just get x squared equals 2x plus 3. Whatever I pull out of there, then I need to solve that. This one's a quadratic, so I'm going to get it equal to 0 because that's how we solve quadratics. And be careful, because remember it's a log, there might be extraneous solutions. Factor, solve, check. So when you check your answer, what happens when I plug a 3 in here? I get ln of 9 equals ln of 9, right? That's good. What happens when I put in a -1? I think it's actually going to work. -2 plus 3 is 1, right? So they both work this time because both of these came out to positive answers. If this had just been an x and not squared, then this one wouldn't have worked because it would be taking a log of a negative. So make sure you check your answers. I'm sure there's another one with that. Oh, no, that's just an application. Half-life, they're going to give you a formula. Okay, let's call it bare so that you can have more time to work. So general strategies. If it's, let's see, if it's, so get the same base. For exponential, if you can get the same base, that's good. If you can't, then you switch to log base 2 of 5. So if I'm stuck here, I don't know what that power is, I switch to log, then that's just a number in my calculator. I can solve that. I didn't actually see much like that. And the same thing with log. If I have log of something equals log of something, I can just cancel out my logs. They didn't have one like this. If you have log of 2 plus log of x equals log of 10, how would you start that one? I'm going to make this one up. You can't cross them off because there's not 1 and 1. How do I get 1? Which the rule is addition becomes? Now you can get rid of them. So that's what I wanted to point out. If there's more than one thing going on, you cannot cross them out. They have to be condensed first. Now I can solve 2x equals 10. The answer is 5. Okay, that's it. Start the homework for 6.6.